Hi, I'm Lindsay and this is Anthony, and today we're going to talk about adding interactions in the visual layer to create customized and responsive experiences. If you're not aware of what the visual layer is, we'd recommend pausing this talk and going and watching Tim and James's talk on Beautiful UI so that you can get the right context for where this is applicable. In addition to that, if you haven't already seen mine and Anthony's talk on expression animations, we'd recommend watching that first since we'll be referring to those concepts a lot.
Okay, so before we jump into the code and the concept, let's take a quick peek at some of the experiences we're trying to enable with the new features we're exposing in the next version of Windows.
So here we have this 3D space, and you can see that as I pan, all of this sticks to my finger, and if I zoom, the same thing happens. And it's a really cool way to have this really responsive UI. It's really interesting for me as a user because I get to interact with it directly. It's pretty smooth.
Yep.
So let's take a step back and figure out exactly how we did this. In that last example, I talked about input kind of driving these animations, but what does an input-driven animation really mean? In frameworks today, there's controls like a scroll viewer, or maybe a list view, that you're basically taking users' input and translating it to some sort of output. It's really the same concept. We just want to enable some slightly more customized experiences with it. So for these framework controls, they do a lot of really cool stuff. They're really performant. You get off UI thread input, but you're kind of boxed into what the control itself enables. With the scroll viewer, it's very specific to panning and zooming with a content in a clip, etc.
Right. So we heard some of the feedback from the developer community, and so in the November update, we exposed a new object called the manipulation property set. So what this is, it's a way for you to get a property set that contains the data that's driving that underlying data that's driving that scroll viewer, that list view on screen, and so then you can use that data to then bind expressions to referencing your expressions that you bind to other visual targets, like to create things like sticky headers or simple parallax type of experiences.
Right, so this is a great way to bridge the gap, but you're still somewhat constrained to what the control itself was intended to do. So for the next release of Windows, what we want to do is take this to the next level and do much more customized experiences like what you just saw. We want to basically enable you to build anything with off UI thread input, really smooth, etc. So let's take a look at kind of a Hello World type sample. So if we go ahead and launch our sample here. Oops, this one is not one that we've resized. But so if I go ahead and zoom, you can see it follows my fingers. I can pan. If I get to a boundary, I get a little bit of going on there. I get inertia, etc. It's basically just a really simple scenario. I can do direct manipulation of the surface. One thing to call out is that if this is all you want to do, you wouldn't necessarily go and use this interaction tracker to do it. But what you would do is we want to use it here because it's kind of a simple scenario that makes it easy for us to demonstrate some of the concepts.
Right. You definitely, for those kind of scenarios, you want to use like the built-in scroll viewer controls or list views because you get a lot of the commanding behavior, a lot of the accessibility behaviors already supported for you. You don't have to build those from the ground up. But it's a nice way to kind of frame the rest of this conversation.
Right. So we're going to take a step back and talk about a few concepts before we dive into the code for that sample. So basically what we just saw was a really simple app. In this case, there is a root, a canvas, and a photo. And then there could be other visuals off to the side. But it's basically, they can be anything else going on in your visual tree. You may have heard us reference Interaction Tracker. This is one of the main objects we're introducing this release. And it's basically the state machine that does the crunching of what's happening to make sure the right motion is applied when there's input.
Right. So Interaction Tracker is this new object that we feel is it's really the corner of any type of, the corner piece to any type of interactive UI experiences that you're trying to build with the visual layer or even from XAML. So you'll notice that the Interaction Tracker is not part of the visual tree. Your visual tree is your visual tree. You lay it out however you want to. The Interaction Tracker simply listens to changes on your visual tree, does a lot of number crunching and a lot of producing new values, new output values that you can then use to target or drive expressions or animations that target other visuals in your visual tree.
Right. So one of the other important objects we've introduced to make this all possible is the visual interaction source. This is what actually tells the interaction tracker which visuals to listen to for input, and what type of gestures and stuff like that. This object is associated with something. In this case, we chose the canvas to be our input visual. We listen to input coming in, look at gestures being detected, etc. If it aligns with the right configurations, we'll send that information over to the interaction tracker.
Right. So an interesting tip about the visual interaction source, if you typically want to target or listen for input on a visual in your hierarchy that's stationed. If you're going to be using a visual that's moving around, it's going to take a little bit more work to get exactly the right experience you want. But once you have that visual that you're listening for input on and you connect it to your interaction tracker, the interaction tracker is going to take that data, produce some new values, even produce values with inertia, and then output these values to its properties that you can reference in expression. And typically what you do here is with those values that the interaction tracker is producing, you usually use those to drive other visuals in your hierarchy that are moving.
Right. So if we look at that end-to-end flow, there's user's input coming in. It's going through your visual interaction source. It's being turned into some sort of manipulation data and given to the interaction tracker. The interaction tracker is then outputting bindable properties that you can use with the expression animation engine to provide animation updates that ultimately end up changing your target visuals. So you basically have this end-to-end flow of user input updating target visuals on screen, all without your app getting involved in the pipeline.
Right, and the key point here is target visuals, plural, because traditionally you have, like a scroll where you have one parent, one child, and that's all you got. But with Interaction Tracker, we don't really care about your user, your visual tree. We care about your users. But your visual tree can be whatever it wants to be. We just listen for what input relative to any visual, and you can output it to as many visuals as you want, however you want to.
So let's look back at that sample we showed originally and see how it's actually done. So we go to our interaction tracker. And if we go ahead and look at the actual code to hook this up, it's not as bad as you might think. We have our visuals where we're just getting the composition visuals from the XAML objects again. And then we go ahead and create our interaction tracker and pass in the compositor. Pretty straightforward. Then we have to create our interaction source. What we're going to do here is, like we said, use the canvas visual to create it. Then in this case, we care about changes in X and Y position as well as scale. So we're going to go ahead and enable with inertia all of those axes. Then there's this line that we have here for demonstrative purposes, but it's actually the default mode. Basically, the manipulation redirection mode says that touchpad, meaning precision touchpad input, is going to go directly to driving scrolling and zooming experiences. But your touch input will go to the UI thread, so you need to go ahead and capture it. The reason we do this is that it gives you, as the application, the ability to hit test. But once you pass it over to us, we take it over. There's no more app involvement. Everything stays completely independent of your UI thread. So then we hook up our interaction source to the tracker, and we set these here, max, position, and scale. Basically, this is just saying how far I'm able to scale or scroll. And we don't need to set min here because it just so happens that the defaults of 0 and 1 scale are what we want. Then, like I mentioned, we have to go ahead and make sure we capture the touch input. So we go ahead and capture that on the pointer down since we have a really basic canvas that doesn't require anything special.
Right, so once we were done configuring the inputs and sort of the world for Interaction Tracker, then we have to do something with its output. So in this case, we're just taking the tracker's position, negating it and binding it to the offset of our photo that we're moving around. And we're also taking the scale and applying directly to the photo scale. And so it's almost like a one-to-one mapping or a negative one-to-one mapping.
And that gets us back to what we had before, where we can go ahead and just manipulate the canvas directly. It looks great. It's easy.
Right, and it's all independent of UI thread.
So let's take a look at a sample that is a little more involved, where we can see how you can take this to make a more app UI, more applicable UI. So in this case, we have kind of our little to-do app. So if we go ahead and look at what's going on here, we can see that as I go ahead and scroll, there's a bunch of animations happening together here. We have this little calendar with my appointment fading in. We have the weather fading out. And if I go ahead and flick, you can see that there's actually some inertia that happens. And also, like I said, it works with precision touchpad. So since I have a Surface Book here, I'm able to see that that works as well. And I can go back to panning with my finger. Everything looks nice. It's smooth. It's independent of your UI thread.
Right.
Everything looks great. So let's see how this compares to our Hello World sample. So if we go and look at where we're setting up, let's go ahead and collapse this. Let's look at our actual interaction tracker setup. Here, it's not terribly different than what we did before. We're going ahead and creating the visual interaction source from the background visual. This time we only care about Y input panning, so we're just going to grab that.
What happens to X in scale if they come?
They all just go to your UI thread the same way they normally would. So we're only going to be impacting the Y input.
Right.
Then we go ahead and add our interaction source to the tracker, and then let's look at the output.
Right. So in this case, the output, we're not doing a direct mapping. We're doing something a little bit more interesting. So we keep track of the position relative to the max position, and we kind of normalize it into a progress. And we take the output of that and we write it to our property set. And the reason we do this is because we're using that as almost like a scrub or a timeline for this whole a coordinated set of animations that are running as we transition between state 1 and state 2.
Right. So if you watched our earlier talk on expression animations, then you're aware that property sets are a great way when you have the same calculation applying in a lot of places.
Right.
So if we look at our animation setup for everything that's happening on screen, we can see how it's used.
So something else that we mentioned in our talk on expressions, which, by the way, if you haven't watched it, you may want to press pause and go watch it and come back, and you'll appreciate this even more. So what we do, we create a blend expression, and we're using one of those helper functions that we talked about. This one's doing a linear interpolation between start value, end value, relative to some reference progress property. But what is start and end? Well, we haven't quite defined that yet, but let's go see. So the first time we take that expression, we update what start and end refer to. In this case, it's the min and max, the blur amount between state 1 and state 2. And then we take the expression and apply it to our blurred background visual effect. Then we can actually take the same expression. So we don't have to create a new expression. The expression's already been, at this point, the expression's already been validated for correctness, it's balanced. But we can simply update those parameters for what basically start and end mean, and apply it to a scale of our background image.
Right. So this really hits home the point that the interaction tracker isn't necessarily tied to your visuals. In this case, all we're doing with the tracker's output is driving this progress, which is then being mapped to a bunch of different visual properties on screen.
Right.
And it gets us back to this really cool, fluid, responsive UI where we get to see all of these changes happening together.
Right.
So, heading back over to our slides. We've talked a lot about how you can customize things in terms of hooking up the tracker's output to a particular visual. But one thing we haven't talked about yet is what if you want to actually change the motion of the tracker? So for example, what if you want inertia to be a little faster or a little slower? Or what if you want to do programmatic things like auto-scrolling or jumping up and down a page with an animation? And what about things like snap points where you want to say, oh, well, if I'm 90 to 110, I just should land at 100 because I was close enough. That type of stuff where it's not necessarily, it's about changing the tracker's knowledge of the world more so than just the visual tree.
So if you really just want to change like how much inertia is being applied, or how far you go with inertia, or maybe you want to speed it up or slow it down or change the distance, or if you want to change where your world boundaries are, then there's a couple of simple properties you can set on an interaction tracker. You can change the inertia decay rate, and you can actually change these per axis. You can change maybe the x-axis has the default behavior, but y maybe you turn inertia off altogether, or just tweak it a little bit. And you can also change how far in each direction you go, position and scale.
Right, and all of those properties are actually bindable, so you can animate them using expressions between different values. Then on top of that, your position and scale are actually also able to be set or animated. So if you want to do something programmatic, like I mentioned earlier, you can actually just animate position and scale directly, and all of the whole system of animations you have tied to the tracker's position will be updated with that.
Right.
And if those don't necessarily meet your needs, we also have more complex conditional modifiers. So these are things like I mentioned before, where it's like, oh, maybe I want to, if my rest point was between these two things, I can kind of snap you to this point. And those are all conditional, so you can say, only do that when I'm above a certain velocity. But all of those, even though they'll implicitly change the motion, they don't touch on the fact that you can actually completely customize the motion curve that we're going to use during inertia.
Right. And those conditional modifiers are evaluated at the moment that you enter inertia in the compositor. So there's no latency where there's a round trip back to your app's UI thread. You set it up once, you tell Interaction Tracker how you want it to behave, and under what circumstances you want it to do one thing versus another. We'll listen to that, we'll evaluate it, and we'll make sure the right thing happens. And the way we do that with endpoints is pretty straightforward. If you want to get into customizing not where it's going to land, but how it's going to travel with inertia, then you might want to consider using our motion modifiers. So what's cool about this is that this is really a force-based system, or a system of forces that we animate. So what you're doing is targeting the acceleration of the interaction tracker, and you can target it with an expression. You can say, maybe when I lift my finger above a certain amount, I want to apply a gravitational force that pulls it back down to the ground. Maybe I want it to have a bounce, maybe I want it to smash into the wall, whatever you want it to be. It's up to you. You define the forces. We do have one pre-built-in force, but you can change it if you want to. You can completely override it, rip it out, and put your own boundary behaviors, your own accelerations into the interaction tracker.
Right. So not only are these not pre-canned, but they're evaluated frame over frame to reflect the current state of the world, which lets everything feel really natural. They also interplay with some of the programmatic scrolling, user interactions, all of that stuff. Interaction Tracker rectifies all this information to figure out the right look and feel to have for your app.
So you don't have to worry about, what do I do if the user presses down while I'm animating, and what if the Interaction Tracker will consider input coming from different parts of the system and reconcile everything and produce the value that you care about. And we'll also tell you how things are changing. So if you want to know about, am I in inertia? Have I stopped? How far am I going? Where am I going to land? You can listen to certain changes that are happening to the Interaction Tracker.
Right. So let's take a look at an inertia modifier sample. So if we go ahead and check out our curtain example here, we have a pretty straightforward little sample. Oop, it's going to open the wrong space. So here hopefully you can see it. So basically right now we have this image, and we call it curtain because you can pull it up and see what's behind it. So if we do our default here, we'll see it just kind of comes to rest, as you'd expect. If we check out something like springy, we can see that if we do this, it'll kind of spring like an actual spring force. If we do gravity, we can pull it up and see it bounces. If we kind of do this, we can see it's all completely dynamic. And if we drop it from different distances, it'll be different, just like you would expect in a more physical situation. We also have pillow, where it kind of slowly comes to rest no matter how hard you flick. But basically, there's a whole bunch of customizations we have going on here. So let's take a look at the actual modifier that we had to do for one of these.
Right. Now, it's important to keep in mind that those modifiers, those different motions, those aren't motions that we define besides the default one. Everything else was custom built with this app. So you're free to create your own motions, your own accelerations that get evaluated when you enter the inertia state. You can make it so that it has a custom gravity. Maybe you want to change the gravitational pull based on some property set. It's up to you. You can define that.
Right. So here we're going to look at the gravity force that we happen to create. All of the other forces will be available for you to check out on our team GitHub, but this is the only one we're going to walk through right now.
Right. This is pretty straightforward. We basically, so first of all, we're saying that the condition is true. Basically, always use this when you enter inertia. So if you have you can define a series of them, and whichever one comes true first, we'll pick that one. We'll select that guy and run it when we go into inertia. But in this case, we only have one. We set it to true, and we say when the position of the object is above our ground, so it's above 0, then use our gravitational force. So basically, again, this is acceleration. So we define a gravity constant, and we pull back to the ground with that. But after we hit the ground, we kind of reverse it and have a force that shoots us up the other way, and we apply a certain amount of bounciness based on some parameter that we set.
Right. So this gives us the effect we saw before, where basically the content ends up bouncing up and down. So there's a lot of pretty cool customizations you can do there. Now, we showed this demo in the beginning, and we're not going to necessarily walk through it in detail here, but it'll be available for you to go check out. But now that based on everything we have talked through, you can kind of see how this is possible. We have input coming in completely independent of our UI thread. We have basically this kind of everything hooking up to our panning input, our zooming input. We have the ability to animate effects, things like that. Right. So we can see how all of this kind of comes together, and you could easily build something like this using all of these components.
Right. Your UI, your visual UI and experience in the tree is completely independent of how interaction is happening. You're in control of what you want to do with that input and how to update your UI.
So that's all we have today. But like we said, if you really like everything you saw here from our team, you should definitely check out our team GitHub. It's a great place to see everything that you've heard us show or seen us show here. It's also a way to ask us questions, talk to the engineers directly. It's a really great way to talk to our team. You can also follow us on Twitter to get updates on the SDKs that we're dropping, the new samples we're releasing, all that kind of stuff. And yeah, definitely check out other build talks on Channel 9. Thanks for listening. Hope you enjoyed.
See ya.